Long before modern telescopes, satellites, and space probes allowed humanity to explore the universe, the night sky was still a deep mystery. People looked upward and saw wandering lights moving slowly among the stars. These wandering lights, which we now call planets, followed paths that seemed strange and unpredictable. Sometimes they moved forward across the sky, sometimes they slowed down, and sometimes they appeared to move backward. For centuries, scholars tried to explain these movements using complicated systems of circles within circles, believing that the heavens must move in perfect shapes because the universe itself was thought to be perfectly designed. But hidden within the quiet motion of the planets was a different pattern, one that no one had yet fully understood. The man who would eventually uncover that pattern was Johannes Kepler. Johannes Kepler was born in 1571 in the small town of Walderstadt in the Holy Roman Empire, an area that is now part of modern Germany. His early life was far from easy. His family struggled with poverty, and stability was often uncertain. His father worked as a mercenary soldier, frequently leaving home for long periods of time to fight in distant conflicts. Because of this, Kepler grew up in a household where resources were limited and life could change quickly. His mother, Katerina, managed the home and sometimes prepared herbal remedies for neighbors, a practice that later caused suspicion during an age when fear of witchcraft still lingered in many communities. As a child, Kepler was often sick and physically weak. Illness left him with poor eyesight and fragile health, making outdoor labor difficult. Yet his mind was alert, thoughtful, and filled with curiosity. While other children played or worked, Kepler often found himself observing the world quietly. He listened closely to teachers, absorbed ideas quickly, and developed an early fascination with numbers and patterns. Two events from his childhood left particularly strong impressions on him. When he was about 6 years old, his mother took him outside one evening to see a brilliant comet that appeared in the sky in 1577. The comet stretched across the darkness with a glowing tail, moving slowly among the stars. For the young boy, the sight was unforgettable. It was a reminder that the heavens were not fixed and unchanging, but alive with motion. A few years later, he witnessed a lunar eclipse. As he watched, the bright full moon slowly darkened as it passed through Earth's shadow. The moon gradually turned a deep reddish color before returning to its usual brightness. The experience fascinated him. Something about the predictable rhythm of these celestial events suggested that the universe might follow hidden rules waiting to be discovered. Despite his difficult circumstances, Kepler showed remarkable talent in school. His teachers noticed his strong ability in mathematics and reasoning. At a time when education was often reserved for those with wealth or influence, Kepler was fortunate to receive scholarships that allowed him to continue his studies. These opportunities carried him through a series of schools and eventually to the University of Tübingen. At the university, Kepler originally studied theology. His goal was to become a Lutheran minister, and much of his education focused on religious texts and philosophical ideas about the nature of the universe. Yet, during these studies, he encountered a controversial scientific idea that would change the direction of his life. This idea came from the Polish astronomer Nicholas Copernicus. Copernicus had proposed that the Earth was not the center of the universe. Instead, he suggested that the sun stood at the center, with the Earth and other planets moving around it. At the time, this idea was considered radical and even dangerous. For centuries, the traditional belief had been that the Earth remained still while the heavens revolved around it. But Kepler was deeply intrigued by the Copernican model. To him, the idea seemed elegant and mathematically beautiful. If the planets moved around the sun, their strange wandering patterns across the sky might finally make sense. Kepler began studying astronomy more intensely, exploring the mathematical relationships between planetary motions and the structure of the universe. For Kepler, the universe was not chaotic or random. He believed it was built according to precise mathematical harmony. Just as music followed patterns of rhythm and proportion, he believed the heavens must also follow mathematical laws. In 1594, Kepler accepted a position as a mathematics teacher in the Austrian city of Graz. There he taught geometry, astronomy, and mathematics to students while continuing his own research into the structure of the cosmos. During these years, he wrote his first major scientific work, attempting to explain why the planets were spaced the way they were in the solar system. He believed their distances might correspond to geometric shapes known as the Platonic solids, which had fascinated philosophers since ancient Greece. Although this early theory later proved incorrect, it revealed something important about Kepler's way of thinking. He believed deeply that the universe followed logical patterns that could be uncovered through mathematics and careful study. At the same time, Europe was entering a turbulent period of religious conflict and political tension. Differences between Protestant and Catholic communities created uncertainty across many regions. Living and working in Graz became increasingly difficult for Kepler because of his religious beliefs. Yet even during these challenging years, he continued studying the motion of the planets. He sensed that the heavens were hiding a deeper truth, one that could be revealed if someone had access to precise enough observations. That opportunity would arrive when Kepler met one of the greatest observational astronomers of the age, a man who had spent decades measuring the positions of planets with extraordinary accuracy. His name was Tycho Brahe, and the partnership between Tycho Brahe's careful observations and Johannes Kepler's mathematical imagination would soon lead to one of the greatest breakthroughs in the history of astronomy. Johannes Kepler's life changed dramatically when he began working with the Danish astronomer Tycho Brahe. At that time, Tycho Brahe was already famous throughout Europe for his extraordinary observations of the heavens. Long before telescopes were invented, Brahe had built massive instruments designed to measure the positions of stars and planets with remarkable precision. Night after night, year after year, he carefully recorded the movements of celestial bodies across the sky. His observatories were filled with large brass measuring devices, carefully aligned to track the slow motion of the planets against the background of distant stars. These records became the most accurate astronomical data ever collected in the pre-telescope era. For Kepler, access to Brahe's observations was an incredible opportunity. Until then, most astronomers had been forced to rely on rough measurements that made it difficult to understand the true motion of the planets. Brahe's data, however, was astonishingly precise. It was detailed enough to reveal patterns that earlier astronomers had never been able to see clearly. Kepler understood that hidden somewhere inside these numbers might be the key to unlocking the true structure of the solar system. The relationship between the two men was not always simple. Tycho Brahe was proud of his achievements and protective of his observations, while Kepler was eager to analyze the data as quickly as possible. Despite occasional tension, Brahe recognized Kepler's mathematical talent and allowed him to study the motion of the planet Mars, which had long puzzled astronomers. Mars appeared to wander across the sky in strange ways, sometimes moving forward among the stars, and at other times seeming to slow down or even move backward for a short period. These confusing movements had forced earlier astronomers to create extremely complicated models filled with circles within circles in order to explain what they saw. Kepler believed there had to be a simpler explanation. After Tycho Brahe died in 1601, Kepler inherited the responsibility of completing the analysis of the vast collection of observations. He now had full access to the detailed measurements that Brahe had gathered over decades of careful work. With stacks of papers filled with numbers and diagrams, Kepler began the long and demanding process of studying the motion of Mars. The task was far more difficult than he had expected. At first, Kepler tried to fit the orbit of Mars into the traditional belief that planets moved in perfect circles. For centuries, astronomers had assumed that circular motion must govern the heavens because circles were considered the most perfect and harmonious shape. Kepler attempted countless calculations, adjusting the position of the orbit, shifting the center slightly, and testing different combinations of circular paths. Yet every attempt produced small errors when compared to Brahe's precise measurements. Those errors were small, but they refused to disappear. Again and again, Kepler recalculated the motion of Mars. He checked every number, reviewed every measurement, and repeated the calculations from different starting points. Sometimes the predicted position of Mars differed from the observed position by only a few minutes of arc, an extremely tiny angle in the sky. Yet Kepler knew that Tycho Brahe's observations were accurate enough that such differences could not be ignored. Many astronomers might have accepted these small discrepancies and adjusted the model slightly to hide the errors. But Kepler refused to compromise. He believed that if the model did not match the observations perfectly, then the model itself must be wrong. For months, and then years, he continued his calculations. Sheets of paper filled with numbers surrounded him as he searched for the correct mathematical pattern. The problem became almost an obsession. Kepler once described how the motion of Mars seemed to resist every attempt to explain it using circles. Slowly, a new possibility began to emerge. What if the planets did not move in perfect circles at all? This thought challenged one of the oldest assumptions in astronomy. For nearly 2,000 years, scholars have believed that celestial motion must be circular. Yet the stubborn data from Mars suggested something different. After long reflection and careful testing, Kepler realized that the orbit of Mars could be explained perfectly if the planet moved not in a circle, but in a slightly stretched shape known as an ellipse. An ellipse resembles a flattened circle with 2 points called foci inside it. Kepler discovered that if the Sun was placed at one of those points, the motion of Mars suddenly matched Brahe's observations with remarkable accuracy. This insight was revolutionary. It meant that the planets were not moving in perfect circles after all. Instead, they traveled in elliptical paths around the Sun. The discovery solved the long-standing mystery of Mars's motion and provided the first true description of planetary orbits. From this breakthrough, Kepler developed what would become known as his first law of planetary motion. It stated that planets move around the Sun in elliptical orbits, with the Sun located at one focus of the ellipse. But Kepler did not stop there. As he continued analyzing the data, he noticed another pattern in the motion of the planets. They did not travel at constant speeds along their orbits. Instead, they moved faster when they were closer to the Sun and slower when they were farther away. By carefully studying these changes in speed, Kepler discovered another precise mathematical relationship governing planetary motion. This became his second law, which described how a line drawn between a planet and the Sun sweeps out equal areas in equal periods of time. In simple terms, it meant that the planets adjust their speed in a way that maintains a consistent relationship with their distance from the Sun. These discoveries transformed astronomy. For the first time, the motion of the planets could be described by clear mathematical laws that matched observation perfectly. The heavens were no longer mysterious wandering paths governed by complicated circles. Instead, they followed elegant and predictable patterns. Yet Kepler himself did not see these laws as merely scientific results. To him, they represented the discovery of a deeper harmony in the universe. He believed that the mathematical relationships guiding planetary motion revealed the underlying order of creation itself. And as he continued studying the heavens, he would soon uncover one more remarkable relationship connecting the motion of all the planets in the solar system. After uncovering the first 2 laws that describe how planets move around the Sun, Johannes Kepler continued his work with a sense of quiet determination. The discovery that planets traveled in elliptical paths had already changed the foundations of astronomy. For centuries, scholars have believed that celestial bodies must move in perfect circles, yet Kepler's careful study of Mars had revealed that nature followed a slightly different design. Instead of perfect circles, the planets traced gentle oval paths, speeding up and slowing down as they traveled around the Sun. But Kepler believed that the story of planetary motion was not yet complete. He had solved the puzzle of Mars, yet the solar system contained many planets, each following its own path through space. Mercury moved quickly near the Sun. Venus followed a slightly wider orbit. Earth traveled steadily through the seasons, and the outer planets such as Jupiter and Saturn took many years to complete their slow journeys around the sky. Kepler wondered whether all these motions might follow a single unifying pattern. For years, he continued studying astronomical data, comparing the orbital periods of planets with their distances from the Sun. This work required long hours of calculation. In the early 17th century, there were no calculators or machines to assist with mathematics. Every step had to be written by hand, each multiplication and division carefully checked before moving forward. Kepler filled page after page with numbers. At first, the relationships between planetary distances and orbital times appeared confusing. Some planets completed their orbits quickly, while others moved slowly through the heavens. Yet Kepler sensed that hidden behind these differences was a deeper mathematical connection. Gradually, after many attempts and repeated calculations, a remarkable pattern emerged. Kepler discovered that the square of a planet's orbital period was related to the cube of its average distance from the Sun. In simpler terms, planets that traveled farther from the Sun took longer to complete their journeys, but they did so according to a precise mathematical relationship. This discovery became known as Kepler's third law of planetary motion. With this final insight, Kepler had revealed a complete set of laws describing how planets move through space. The three laws together explain the shape of planetary orbits, the changing speeds of planets along those orbits, and the relationship between their distances from the Sun and the time required to complete each orbit. Although Kepler did not yet know the physical reason behind these patterns, his work provided an accurate mathematical description of the solar system. Decades later, Isaac Newton would use these laws to develop the theory of gravity, explaining why planets move the way they do. In this way, Kepler's discoveries became one of the crucial foundations of modern physics. Yet Kepler's life during this period was far from peaceful. Europe was entering a time of deep political and religious conflict known as the 30 Years' War. Armies moved across regions of Central Europe, towns and cities faced hardship, and the lives of scholars were often disrupted by the instability around them. Kepler himself faced many personal struggles. Financial difficulties were constant, and he frequently moved from one city to another while seeking positions that would allow him to continue his work. His family life was also marked by hardship. Several of his children died at young ages, a tragic reality that many families faced during that time due to disease and limited medical knowledge. Perhaps the most difficult challenge came when his mother, Katharina Kepler, was accused of practicing witchcraft. During the early 17th century, fear of witchcraft was widespread across parts of Europe, and accusations often led to serious trials. When Katharina was arrested, Kepler devoted years of effort to defending her in court. He studied legal arguments carefully, wrote detailed documents in her defense, and worked tirelessly to prove her innocence. After a long and difficult legal battle, Katharina Kepler was eventually released, though the experience deeply affected the family. Despite these personal hardships, Kepler continued his scientific work with remarkable persistence. During these years, he also wrote several important books explaining his discoveries. In these works, he described the laws of planetary motion and provided detailed explanations of how he had arrived at them through observation and calculation. His writings allowed other scholars across Europe to study his results and apply them to their own understanding of astronomy. Kepler also became interested in the new invention of the telescope. When Galileo Galilei began using telescopes to observe the heavens, revealing mountains on the moon and moons orbiting Jupiter, Kepler carefully studied these discoveries. He wrote about how telescopes worked and helped improve the understanding of optical lenses, contributing to the development of better instruments for observing the sky. Throughout his life, Kepler remained deeply convinced that mathematics was the language through which the universe could be understood. To him, the motions of the planets were not random events, but part of a larger cosmic harmony. The laws he discovered revealed a structure in the universe that was both precise and elegant. Even as wars spread across Europe and personal challenges filled his daily life, Kepler continued exploring the patterns of the heavens, believing that the quiet movements of the planets reflected a deeper order waiting patiently to be understood. As Johannes Kepler grew older, his discoveries about the motion of the planets slowly began to spread among scholars across Europe. The three laws he had uncovered were not simple guesses or philosophical ideas. They were based on years of careful calculations and the extremely precise observations gathered by Tycho Brahe. Together, these laws describe the true structure of planetary motion more accurately than any system that had existed before. For the first time, astronomers could predict the positions of planets with a level of precision that had previously seemed impossible. Yet during Kepler's lifetime, recognition for his work came slowly. The early 17th century was a difficult time for scientific communication. Books had to be printed and distributed across long distances, and many scholars still held firmly to older beliefs about the universe. The traditional view that planets moved in perfect circles remained deeply rooted in the thinking of many astronomers. Because Kepler's elliptical orbits challenged this long tradition, some scholars were slow to accept his conclusions. Despite these challenges, Kepler continued to write and publish his findings. His books carefully explain the reasoning behind his discoveries, showing step by step how the observations of Mars and the other planets led to the laws of planetary motion. These writings required enormous effort. Each calculation had to be performed by hand, and the results were often checked many times to ensure accuracy. Kepler believed strongly that careful evidence in mathematics would eventually convince others of the truth he had discovered. During this period, he also worked as an imperial mathematician for the Holy Roman Empire. This position required him to prepare astronomical calendars and predictions of planetary positions, which were important for navigation and timekeeping. Such work provided him with a modest income while also allowing him to continue studying the heavens. His calculations helped sailors, scholars, and navigators better understand the rhythms of the sky. Even as he carried out these duties, Kepler remained deeply interested in the deeper meaning of the universe. He often wrote about how the mathematical patterns of planetary motion reflected a kind of harmony in nature. To him, the movements of the planets were not merely mechanical events, but part of a grand structure governed by precise laws. This belief inspired him to continue exploring connections between geometry, astronomy, and the physical world. Kepler also contributed important ideas to the field of optics. He studied how lenses bend light and explained how telescopes could be improved by arranging lenses in new ways. These insights helped astronomers design better instruments for observing distant objects in the sky. As telescopes gradually became more powerful, the accuracy of astronomical observations improved, confirming the patterns Kepler had described through mathematics. Over time, the influence of his work grew steadily. When later scientists studied the motion of the planets, they found that Kepler's laws matched observations with extraordinary precision. One of the most important figures influenced by Kepler's work was Isaac Newton. In the late 17th century, Newton developed the theory of gravity, explaining that every object in the universe attracts every other object with a force that depends on their masses and the distance between them. Using Kepler's laws as a guide, Newton showed that gravity could explain why planets move in elliptical orbits around the sun. The laws Kepler had discovered through observation and calculation became the foundation upon which Newton built his theory of motion and universal gravitation. In this way, Kepler's work formed a crucial bridge between ancient astronomy and modern physics. Despite the significance of his discoveries, Kepler's personal life remained difficult in many ways. Financial problems followed him for much of his life, and the political conflicts of the 30 Years' War created instability across the regions where he lived and worked. Travel was often dangerous, and cities frequently changed control between opposing forces. In 1630, while traveling in search of payment for work he had done as imperial mathematician, Johannes Kepler became ill. He died later that year at the age of 58. At the time of his death, the full importance of his discoveries was not yet widely recognized. Yet the mathematical laws he had uncovered would continue influencing scientists for centuries to come. Today, when astronomers study the motion of planets, moons, and even distant exoplanets orbiting stars far beyond our solar system. They still rely on the principles first described by Kepler. Spacecraft sent to explore other worlds use calculations based on his laws to navigate through the solar system. The paths followed by satellites, probes, and planets all reflect the same mathematical patterns he uncovered through patient study. Johannes Kepler's life shows how powerful careful observation and persistent reasoning can be. Working with little more than handwritten calculations and the observations of the night sky, he discovered the hidden rules that govern the motion of worlds. His work revealed that the universe is not random, but follows precise and elegant laws, waiting to be understood by those willing to observe patiently and think deeply. Through his dedication to mathematics and his belief that the cosmos followed an underlying harmony, Kepler helped humanity take one of its most important steps toward understanding the structure of the solar system and the wider universe beyond.